Go. Hey everyone. So we are going to look at two examples, one with half-life and one with Newton's law of cooling. I have a special guest here next to me. Her name is Isabel. She's my daughter. She is going to help us through. Come on. That's her. You can say hi. Hi. Okay. So we're going to go through two examples, one with half-life and one with Newton's law of cooling. And then next block we can take a look at it closer if you'd like. So let's start with half-life. So the half-life of plutonium-239 is 24,000 years. You're going to find the amount of plutonium of 735 grams after 10 years, and then how long it will take for it to reach 155 grams. So the half-life formula was given to you like this, just so you know. A sub 0 is your initial amount, how much you're starting with. T, as always, is time, and that's going to be determined based upon the problem you're given. In this case, we're talking about years. And then H is how long it takes for it to become half. So if we have 735 grams of something 24,000 years later, you're going to have half of that amount left. Okay. So the first question is asking you to find the amount after 10 years. No, after 10 years. So this is kind of like a plug and chug here. So we have 735 for our initial amount. The 1/2 is always 1/2. That makes the half-life. And then we have time is 10 because of the 10 years over the 24,000 years. So these two things need to be in the same units if they're not for the future. So then you're just going to, this is, like I said, just plug into your calculator, spit out the answer for you there, and you get 734.787 grams. So that's how we would do that one. Versus how long will it take to get 155 grams? So this means we're going to put 155 in for A, and we're solving for T. So the first thing you want to do is to isolate the exponential piece. So we're going to divide. 155 over 735 reduces down to 31 over 147. So now I'm stuck. Anytime that you're stuck, you're going to convert. So this would be log base 1/2 of 31 over 47 equals T over 24,000. And then you can do that log times the 24,000. And so we get 53,891.42 years. That's how long it would take for that specific thing, the plutonium, to get down to 155 grams. Okay? Which should make sense. It should be a long time because it takes 24,000 for it to get cut in half. So if we're going down to 155, we're going to have to take quite a bit of time to do that. Okay? So that's our half-life type problems. Okay. So then let's take a look at the Newton's law of cooling. I'm sorry that my face is blocking everything out over there. The brewing pot temperature of coffee is 180 degrees Fahrenheit. The room temperature of this problem is 76 degrees Fahrenheit. After 5 minutes, the temperature of the coffee is 168 degrees. How long will it take for the coffee to reach a serving temperature of 155 degrees? So this is Newton's law of cooling, the formula for it here. So to give you some information about that, the T sub 0 here, that's initial temperature. So in this problem, it tells you that information. Then we have T sub m, which is the 180 for the initial. The T sub m is the surrounding temperature, so what is it in the room, which in this problem it says it's 76 degrees, and then K is the decay factor. So in this problem, I don't have the decay factor, so the first thing you're going to have to do is find that. So let's see the information I have. I've got T sub 0 is 180, so that's the initial temperature of what the coffee is at that time. T sub m is the surrounding temperature. And the other piece of information is we know after 5 minutes, it became 168. So this is what we're going to be using to help us identify what K is. Because we have Tm, we have T0, and we don't know what, and we need to find K. So we need to fill something in for T, and we need to fill in something for what you would think of like the Y equals, or the amount that it comes over, T at T, the function notation there. So if we fill in the values here, I'm putting 5 in for T and 168 in, given this because of this piece right here. 76, because that's the T sub m, and then 180 minus 76. And we're going to go ahead and try to isolate the E. So I'm going to subtract 76, and at the same time I'm going to do 180 minus 76. And then I'm going to divide by the 104, and reduce, getting down to 23 over 26. And now I'm stuck, so we're going to convert to a natural log this time. So natural log of 23 over 26 equals -5 times K, and then I'm going to divide. So that's the first thing you're going to do, is to identify the the K value. So in this one, it ends up being 0.0245. And then from there, we can now answer the question is how long is it going to be 155 degrees? So when we're putting numbers back into here, the 155 is going to go into here. Now I know that the K is going to be the 0.0245. So the first thing is to solve for K. Then from there, we're looking for time. So we're trying to solve for T. So everything in this should be filled out except for the T. So T sub 0 is 180, T sub m is 76, and we're looking for at what times are going to be 155. So I'm going to plug in my respective values here. Now I know what the K was. It was the 0.0245. So I'm going to subtract and divide. Once again, I'm stuck. So I'm going to natural log of 79 over 104 and divide by the negative 0.0245, and we get 112 minutes. Okay, so a little shy of 2 hours it would take for it to be 155 degrees according to this. Okay, great. So you're going to spend the rest of the block just working through and practicing all types of problems that we've been working on. And if you have any questions about this or the half-life, feel free to bring them next block. I will be checking homework as well as this worksheet that you're going to be working on today next block. I'll see you on Thursday.